All right, this lesson is Unit 2, Lesson 12. We're talking about variation functions, and if you want to check this lesson out in the textbook, it can be found in Chapter 8, Section 5. We have a content standard for this lesson, and the content standard says that we need to create equations in two or more variables to represent relationships between quantities. It also says graph equations on coordinate axes with labels and scales, but we're not going to be doing any graphing in this lesson. We have two mathematical practices to focus on. The first one is making sense of problems and persevere in solving them. And the second one is modeling with mathematics. So many times already in your algebra career, you have written and graphed linear equations. And in this lesson, we are going to we're going to recognize and solve direct and joint variation problems, and also recognize and solve inverse and combined variation problems. So direct variation might be new vocabulary to you, but it's something that's supposed to be covered in Algebra 1. Same with inverse variation, same with constant of variation. Those are all topics that are covered in Algebra 1. But joint variation and combined variation are definitely new topics that are not covered in Algebra 1 that are going to be new to Algebra 2. So hopefully you can remember, even if it's vaguely, that direct variation, the formula for that is y equals kx. Basically the concept here is if one thing goes up, the other thing also goes up. So let's look at an example with direct variation. So it says if y varies directly as x, so the key word here is directly. We want to know that, like that word tells us that we're going to be doing direct variation. If y varies directly as x, and y equals 15 when x equals 5, find y when x equals 3. And so this is as simple as setting up a proportion. So we're going to use negative 15 over 5, and then y over 3. We're not sure what that y value is. You're going to cross multiply, you're going to simplify, you get your answer of negative 2. Or negative 9, sorry. Wow, I completely read that wrong. The answer is negative 9. So when x is 3, the value of y is negative 9. Here's a check your progress problem. It's pretty simple. When you have your answer, go on to the next screen. Okay, our answer for this problem is A, negative 28. Key here is that y is negative 4 times whatever x is. So if you just multiply 7 times negative 4, you get negative 28. Joint variation. Joint variation is when y varies jointly with two different variables. And joint variation is a kind of direct variation, except instead of just y equals kx, it's y equals k times xz. There's two variables. So we have our example for that, and it says, suppose y varies jointly as x and z. And whenever you see the word jointly, you need to think of direct variation again. It's still the same format of equation. And it says, find y when x equals 10 and z equals 5, if y equals 12 when x is 3 and z is 8. So if we use the joint variation formula y equals k times xz, the way that they're getting these proportions is basically you solve for the variable k. So I'm going to write that formula over here, y equals k xz. So if you solve that equation for k, you're going to have to divide both sides by xz, and that's how they get this proportion over here. So we're setting up two different scenarios. And the first scenario is the first part where it says find y when x is 10 and z is 5. That's going to be all their 1s. Or it could be your 2s. It really doesn't matter which one it is. And the second scenario, find y is 12 when x is 3 and z is 8. That would be the other side. And you can see they use the second scenario as the first part, which is fine. It doesn't really matter which part it is. But when you simplify this stuff, they're going to cross multiply again. This side over here, 120 times 5, that would be 600, and then 3 times 8 is 24, so we're going to end up dividing both sides by 24. and we get the value of y is 25. And that's your answer. When x is 10 and z is 5, y is 25. All right, check your progress problem. Same process. Y varies jointly as x and z. Pause the video when you have your answer, go on to the next screen. And our answer for example 2, check your progress, is D, 3/5. All right, the next concept is inverse variation. Inverse variation, the formula changes to y equals k over x. The concept here is when one term gets bigger, the other gets smaller. So for direct variation, if one gets bigger, the other gets bigger. If one gets smaller, the other gets smaller. But for inverse, when one goes up, the other goes down. So example 3, if r varies inversely as t, and r is -6 when t is 2, find r when t is -7. So if we go back to this other screen, we have k equals xy. If you solve this equation for k, we'd multiply both sides by x, obviously. That's the proportion they're going to set. They're going to set up x1, y1 is going to equal x2, y2. So here we have -6/2 is going to equal the unknown over -7. Oh, sorry. Notice here they have R1, T2. They flip the signs. The other way of saying this, actually let me use the pen to write this. When you solve the direct variation equation, or the inverse variation equation, sorry, and you get k equals xy, they're not setting it up this way, but another way that you could solve this problem, which I think might be easier, is to say if r varies inversely as t, r is -6 when t is 2. So we could say r is our x and t is our y value. So that's -12. If we multiply those together, that's going to equal r times -7. -7 r. And then if you want to solve for r, obviously you divide both sides by -7. And this fraction just simplifies to 12/7. And we'll hopefully see that same answer on this next screen. There we go, 12/7 for r. So if you're watching this video, they set up their problem a little bit differently. I think the way that I just wrote it on the screen is going to make it simpler to understand. In class, I'm going to explain it the way I just wrote by hand on this presentation. I'm not going to do it the way they did it because I think my way is a little bit simpler. Check your progress problem. If A varies inversely as B and A is 3 when B is 8, find A when B is 6. So pause the video as long as you need. When you have your answer, go on to the next screen. Your answer this time is B is 4. Or not B is 4, but choice B. The value of A is 4. All right, example 4, we have a real world problem. It's about space. It says the apparent length of an object is inversely proportional to one's distance from the object. Earth is about 93 million miles from the sun. Venus is about 67 million miles from the sun. How much larger would the diameter of the sun appear on Venus than on Earth? So the key here is it's inversely proportional. So we need to think of the equation again. K is going to equal x times y. So our first our first x and y, our first L and D, because they're using L as the apparent diameter and D is the distance of Venus from the sun. L2 is the apparent distance of the sun from Earth, for L1 was the sun from Venus, and D2 is the distance of Earth from the sun. So we know each distance, but we don't know the apparent diameter. What we're going to say is that the apparent diameter of the sun from Earth is just going to be 1. We don't know how much it is. It's going to be 1 unit. So how wide does the sun look when we're on Earth? That's the concept of what we're thinking about. We're going to call it 1. So x times y, or L times D, 1 times 93 million, is something times 67 million. So we're going to solve for that something, divide both sides by 67. We get V is about 1.39. So however wide the sun actually is, if you could somehow travel to Venus and look at the sun, then somehow if you were able to somehow travel over to Venus and look at the sun would appear to be 1.39 times as big or as wide the diameter on Venus as it appears to be on Earth. So for Venus, the diameter of the sun will appear about 1.39 times as large as it appears from Earth. So here's our real world problem, check your progress problem. Go ahead and read through the problem, pause the video as long as you need. When you have your answer, go on to the next screen. And our answer to this problem is D, 0.65 times as big. Okay, last thing, combined variation. Combined variation is another type of inverse variation. So our problem says we need to suppose that f varies directly as g and varies inversely as h. We need to find g when f is 6 and h is negative 5, if g is 18 when h is 3 and f is 5. So because we have direct variation and inverse variation, we're going to be combining the two different kinds of variation formulas, which is why it's called combined variation. So our formula for this, the way to set up the proportion, is you're going to say that F1 is K times G1 over H1. So the direct variation shows up with the concept of F equals K times G, and the inverse variation shows up as F equals K over H. So we're kind of combining different topics when we do combined variation. So we need two different equations. In the first equation, we're going to use 1 as the subscript for all of our variables f, g, and h, and in the second equation we're going to use 2 as our subscript for all of the variables. And then we're going to solve each equation for k. Basically when we do that, we are going to multiply each side of the equation by h over g. So we get k is f times h over g for each one, and we're going to set these two expressions equal to each other. So when we do that and then we plug in the values that we're given, we get, right here, this is 15 over 18 equals negative 30 over G2. We're going to cross multiply, simplify everything and solve. We get G2 as negative 36. And so when f is 6 and h is negative 5, the value of g is negative 36. All right, we've got to check your progress problem. Pause the video as long as you need. When you have your answer, go on to the next screen. And our answer for this one is 40. G is 40 when f is 6 and h is negative 16. Okay, that's the end of Unit 2, Lesson 12 on variation functions.